Multics, a study, an examination of its structure. I forgot the title exactly. And they said, read this. Don't bother us. Well, for an abstract mathematician, and reading Organic's book on an operating system was really hard. I had never taken a computer science class, but it was kind of a self-education. I learned a lot of good things. In fact, in later years, when someone would say, we need you to write a model for this system, I'd say, fine, where's Organic? It turns out, for other operating systems, there isn't an analog of Organic. So off we went to go do this, and we did this. Now, these sets of rules, which are actually kind of governors for particular changes of state, are not all the same. We got rows up here and R's down here. We got tired of having to put rows in place. Now, these are not obsoleted. They're still available, and in fact, in later life, the multics specific ones were less useful than some of the earlier ones. So, off to do modeling work, we were building a toolkit, and as sort of an independent study, I had to go off and learn a little something about operating system design and theory. And every time I saw an operating system, there tended to be characteristics that I wish it had that multics had in the first place. I already alluded to the fact that the engineers and we conceptual thinkers had an interesting relationship. And when you are trying to do this in general, you can think of three basic time sequencing. One is you can have the engineers go and then think about conceptually when they're done. Well, the downside here is that they've painted you in the corner, you're hosed. You know, you have the same problem if you have the conceptual people go first and the engineers later, because the conceptual engineers could define anti-gravity, and then the engineers are in trouble. They can't do it. What we did, and I didn't talk about it so much, but the third volume that I did, it was a refinement of the mathematical model, and there were 3 refinements. Every single one of them came from engineers saying, your early models told us to do this, and we can't. Trusted subjects, people are somewhat aware of trusted subjects. Lee Schiller went downstairs on a task. He had a PDP 1145, and they said, Securify it, use this model. He came storming up a week later. He said, you've got this star property thing that says, I can't open up things simultaneously and read from high and write down. What do I do with my scheduler? My scheduler has to read the unclassified and then write it in order to get it out, and then read the top secret out of storage and make it run. I got to read and write top secret and unclassified at the same time. So that's one example. So you know, he was indignant, and I was abashed, and I said, well, you know, you've got a good point. And so we changed the definition of star property to say you have a choice. If you are unexamined, you have this rigorous limitation. If you don't want that limitation, someone has to assure, through whatever means, that if you open up those two things, you will not do the bad thing. And the bad thing is putting highly classified stuff into a low classified object. So my view is that that's probably the right thing to do. The similar issue came up when people were doing formal verification of the Blacker system that had to go to A1. They had designers and they had formal verifiers. And they ended up with a similar kind of dilemma. You take either community and have them go first, you're going to, you know, you could paint the other people into a corner. So you really have to have them talk and sort of shuffle together forward, kind of a three-legged race approach. Now, When we had done all of this, worked all of this through, 15, 20 years, people worked on how to figure out how to do good, secure systems. The government needed them, but unfortunately, the commercial people were still not providing them. And we're stuck on kind of a Hobson's choice. The government is really rotten at building and maintaining systems. Now, they can do a skunk works, they can do a proof of concept, but the government doesn't hire people to man help desks and fix bugs and keep software up to date. Just doesn't work, has never worked. And the private sector is rotten at developing real security. I have this blank in my memory. There was an IBM guy of great renown, Bill something, who was going around at that time saying the only problem you have is personnel security. Technical security is a mirage. No, it's Bill Murray's friend. So maybe it's Bob. Yeah. Bob, the pilot with all the good stories. Right. And when one of you remembers it, just shout it out. It'll be great. What the private sector is trying to do is take over the marketplace and make money. And at that time, the marketplace was IBM. That was the marketplace. Now, this is at the time that mini computers were coming out, and not too long until we had smaller computers. So, what does the government do when the commercial systems don't work, they're not giving you real security, and it doesn't work for you to do it? Well, there are only sort of two choices. You can go to the commercial people who build a system that you're otherwise happy with but doesn't have security, and you can write them a contract, pay them money, and they can make you a special version. But the downside is, a couple of downsides. One is that the sharpest people don't want to work on that job. They want to build the next operating system, get their name on the new system that goes out. So you don't necessarily get the top people. But they finish it up, time passes, new version of operating system comes out, and they didn't do yours. So every time the system gets updated, you get to pay them again. Well, that's suboptimal. Doing it themselves, that doesn't work either. At that time, Steve Walker, who had been at ARPA and then was Director of Information Systems at the Undersecretary for RDT&E, decided that there was a third way. And he started something called the Computer Security Initiative. Is this familiar to anybody, the term Computer Security Initiative? There are three parts to it, but this slide has to do with his trying to explain to people how the world is going to change. This is the way in DoD that you procured systems. Time goes down. You start with requirements and you move through this set of steps, specifications, system, and then you get up to a decision point where you need to certify. And you're certifying against a set of explicit requirements and implicit ones that are included by reference. You know, FAR and DFAR and various things that that you have to do in your system. It turns out that a number of these things that you have to certify against relate to security. So the technical engineers who are brought in for this procurement have to master those areas of security well enough to get through. But I've done one acquisition, and everybody I knew who was a technical engineering officer, they did one, and when they were finishing, what they said is, I'm never doing this again. I'm managing my career. I'm never doing an acquisition again. As a result, the good technical officers doing acquisition are always doing it the first time. So even for the security areas, they're doing it for the first time, and some of that stuff is hard. So this is what Steve's suggestion was. This is how we're going to change it. What he said was, what we will do is set up another place, a center, that will do the things that program managers, program offices won't do. Look at the commercial products, determine their security properties. In fact, we will determine it against a standard, except we couldn't call it a standard. So it's a criteria that allows us to say these are the characteristics of these systems. We will then put it on a list called an EPL, name chosen to sound like preferred products list because people are used to the preferred products list. And then these poor engineers who got stuck on an acquisition will only have to deal with what does it mean for this system to have been a B2 and not have to deal with the 3 or 4 other things that are sort of interrelated and overlapping. So that's the plan. So the notion is we will build our criteria, we'll find a place where we get people to look at products and build this EPL. And they won't be under the time pressure of doing an acquisition. The other running joke for acquisition officers was that if you looked at what you were doing, always a tight schedule, and you'd see some technology or some approach that's really promising, first thing you looked for was, has anybody else done it and gotten certified? Because if you haven't, that means if you adopt that approach, you introduce risk. I'm not going to introduce risk because you get graded on doing it on time. So the joke was everybody wanted to be second. This is a great idea, George. Why don't you do it? And because if you do it, I can cite you. As a result, nobody did it. Nobody did the selfless acts that would help the community because they weren't being graded on that. They were being graded on coming in on time. So the notion was that this center, they would do the selfless acts. That'd be their mission. Well, Steve wasn't sure where to put it, but he got fooled by Bobby and then it ended up in NSA. And that's where I ended up going. Now, if we talk just briefly about the why my computer won't talk to him. The criteria was the Trusted Computer System Evaluation Criteria, commonly called the Orange Book. Overall, what we had in here was a distillation of 20 years. And these were 20 years of thinking about it and, in some cases, actually writing code and getting things to run. People who have one idea arguing against people who have published about a different idea. Interchange the marketplace of ideas. You have to define what security you want. The Orange Book said, these are chunks of security we are interested in, we're the military. You need a good conceptual design. It said you will have a model. You need a faithful implementation. In one particular case, somebody who was going through the evaluation, was, conceptually they're sitting there, and the evaluator say, "Do you have a model?" They say, "Yep, got this one." It happened to be Bell LaPadula. Most of them were Bell LaPadula. They say, "You got a design?" Say, "Yep, got a design." Do they relate to each other? We don't know. Well, if you have a really good conceptual design for a chess playing program, but you're doing World of Warcraft, then that conceptual design really has nothing to do with your design. It's the faithful implementation. Show me that this actually informed your design, or that you're consistent with it. So it needs to be a faithful implementation. Write down what you've done so that a third party can check your work. Now, the last piece, there are a number of things that are in the Orange Book that many of them have sort of funny terms.